I would like to present GLORIA variable star demonstrator experiment. After selecting this experiment from the GLORIA user page, you see some basic information about the Eye of the Sky telescopes, about the collected data which are used in this experiment, about the principle of this experiment. If you would like to have more details, you can select to read the detailed manual of the experiment, which is available as a PDF file, or you can also select more detailed information about the subject of the study. It is variable stars. When you already know all the basic facts, you can continue to the actual experiment. The first step in doing the experiment is to select a star which you want to study. There are three options to select a star: from the sky image, from the list of suggested stars, or if you know which star you would like to study, just by giving its coordinates. Let's try the first option, selecting a star from the image. After clicking the image button, you see the image of the sky as seen as the Eye of the Sky telescope in Chile. You can select one of the stars in this image just by clicking it. You click it with a mouse, then the star is indicated by an angle. You see the position of the angle on the picture. When you click check, this position is translated into the sky coordinates. You should also check if you selected exactly one object. Then you can press submit button, and the coordinates which you entered are sent to the LUISA analysis server, which analyzes Eye of the Sky data and reconstructs in real time the light curve of the star. You see here the resulting measurements. On the horizontal axis here you see just the time of observation. You also see that points are in three different colors. These colors indicate the quality of the measurement. 60% of points with the lowest uncertainty, as estimated in the frame calibration procedure, are indicated by green color. Next 20% by orange, and the 20% of measurements with the largest errors are indicated by red color. So it is usually the best solution to remove this worst measurement, so to keep only 80% of points, which you can select by clicking here percent data included button. When you select this 80% and at the same moment the light curve is plotted modulo with time modulo 10 days, you see that the spread of the brightness measurement is relatively low, and there is no pattern visible in this magnitude of variation. So this star is probably not a variable star. Let's come back to the object selection and now try to pick another star which we suspect to be variable. I know this star is a good choice, and I can ask the analysis server to reconstruct the light curve for this star. Here again, we can remove the data with worst quality, but even then we see large variations in the object brightness. We can try to see if this is in fact a variable star by pressing the estimate button. At this moment, a dedicated algorithm tries to find the variability period of this object using the so-called analysis of variance method. And you see that we clearly received a very nice light curve of a variable star. In this case, this is the eclipsing binary star of algal type, so it is a detached binary system. Let's go back again to the object selection page and now select one of the stars from the list. This star we also know to be variable, but not all stars in this list are variable. Users are supposed to verify which ones are. We select this star, and now again we see the reconstructed measurements. We can now keep all measurements, so enter 100% here. And again, we see that there is a large variation of brightnesses measured, which indicates that this can be a variable object. When we press Estimate button, the program starts to estimate the period of variability. And the resulting period in this example is about 7.5 days. And you see that the light curve corresponds to the classical Cepheid star. If we remove the 20% of worst measurements, these red points, which are clearly sometimes not in best agreement with the remaining ones, the quality, oh, sorry, I left only 20%, so we should leave 80%. The quality of the curve clearly improves. If we leave only 60%, it becomes even better. We can estimate the period when only 60% of points are left, and we should give almost the same result as the fit was quite good already at the beginning. But for some stars, the choice of the quality cut is quite important to get the good period estimate. When we are done, we click here I'm done button, and then we are presented with a choice of user feedback forms, which are available in all GLORIA languages. We request users to fill the feedback form, as it's very important to us to know if users had any problems with the experiment and to know if there are things we could improve.